Alrighty. Meeting rooms part 3. I don't recall doing part 2 or 1 or 3 to be honest, even though I solved it at some point previously. You're given an integer n, and there are n rooms numbered 0 through n minus 1. You're given a 2D integer array meetings that has kind of tuples that are start and end of the meeting, half close. Okay, so it's inclusive of the start and exclusive of the end time. All values of start is unique. Okay. Meetings are allocated to rooms in the following manner. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting is delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. When a room becomes unused, meetings that have an earliest original time should be given to the room. Return the number of rooms that are held. Number of rooms that held the most meetings. If there are multiple rooms, return the room with the lowest number. Return the number of the room that held the most meetings. Okay, I guess it's a deterministic allocation of meetings to rooms by the end. So there's always going to be some specific count for each room. It's the same each time. If there are multiple rooms. Okay, so the meeting times are 0 to 10, 1 to 5, 2 to 7, 3 to 4. At time 0, and there's 2 rooms. So room 0 and room 1. So time 0, both rooms are not used. First meeting starts in room 0. Then room 1 would get this meeting at time 1. Then 2 would get this meeting at time 5, which is when the first meeting ends in room 1. So this would be in room 1. And it would go from 5 to 10 because this is 5 long. So it'd be go to 5 to 10 in room 1. And then this one would go from 10 to 11 in room 0. Third meeting 5 to 10, 10 to 11 and 0. Both rooms 0 and 1 have 2 meetings, so return 0. Okay, so here 3 rooms. This is 1 to 20 in room 0, 2 to 10 in room 1, 3 to 5 in room 2, and this would go, so then this thing finishes in room 2, so this would go in room 2 from 5 to 10, and then this would go in room 3, oh no, go in room 1 from 10 to 12. So the most is 1, really. What? Return the number of room that held the most meetings. Oh, the room number. The number of the room. So room number 1. I see. It's not the count I was thinking of. It's the actual room number that has the most meetings. If ties, return the lowest number. Okay. So I think what makes sense here would be some sort of what would make sense here? I think maybe some sort of heap. So there could be at most 100 rooms. Yeah, maybe a heap. Would the heap keep track of the end time for a room? Yeah. And then you sort let's see. Okay, I think return the number of rooms that help us meet. So if I can do, let's say, a count, which is going to be the count of, say, meet count is going to be 0 for each room. And I'm thinking maybe if I consider keeping track of the end time of every meeting and the room that it's being occurred. If there's an open room, then obviously assign to that, but otherwise assign it to kind of the earliest opening. Yeah, so let's say room open room is going to be true for every room at the start, and I think I do need like a time variable. And I think I want a heap, so current meetings. This will be some sort of data structure to keep track of the rooms and their ending times. Heap of tuples where it's going to be end time, comma, room number to track to track to track meetings at current time. Gosh damn. To track current meetings. So I think that's fine. And then eventually the answer will be like the minimum. No, what's the answer going to be? The answer will be, say the max count is going to be maximum of meet count. So whatever the array has at the end for the largest amount of meetings occurring in that room. And then I'll go through the loop for every index and range. And if the meet count of that room at that index is equal to the max count, return that room number. Okay. And the meeting times are not necessarily in order, I don't think, initially. So, oh shoot, meetings is already so assignment, maybe scheduled, and then scheduled or I'll call it active. Active, yeah. I need to sort the meetings. So, and do I want to sort? I want to kind of sort. Yeah, I want to sort the meetings by their start time. Okay, so for every, like, I'll go. I'll use indexing here. I could possibly use a for each loop of all the meetings. So like a for start, comma, end in meetings rather than this, but it might be that I care about the index. Probably not, but I'll change it later. Start and end time is equal to meetings at this index. And then I wonder if maybe I should have a heap for the open rooms, because then I would know what is the smallest open room, taking it off the heap and onto the heap when necessary. Yeah, maybe the open room should be a heap where I initially have all the room numbers available. So this can be 1K for actually I wonder can I just do range n? Does that work? Like normally I would use a list comprehension like k for k and range n, but maybe if I just pass range n. Huh. I've never actually seen I guess if I do k and k in room n, yeah, I guess range is actually a object. So let's say k or k in range n. Yeah, that seems right. Okay, so I have a list that is like 1 through or 0 through n minus 1 inclusive. And then actually I want to make that into a heap. I think that works. Or it could be that I need to use heapify. Yeah, I think I need to use heapify. So you start with the heap, or you start with the array, and then I think I need to do something like heapify open. Should be better about this. Huh. Heapify, when you do that, still is exactly the same. Interesting. Interesting. I wonder if that's just expected. Okay. Maybe I don't need to do that actually. Okay, so start end equals to meetings at this index. And then so I need to compare it with time, I want to say. So there's a couple of things. One is I need to push time forward if the start is if the starting time is after the current time. So I guess start time is always going to be after the current time, no? Yeah, the start time should always be after the current time because it's just in order. Maybe I don't need to care about what the current time is. Okay, so how would that work then? If there is something in open room, then I'm going to take the room number as the smallest open room. I'll definitely want to increase the count of the stuff at that has been assigned to that room number. And then I'll push heap push onto the active heap, the tuple that is the end time of this meeting and the room number. Okay, that's pretty straightforward. And now if there is no open room, then I want to do what exactly? I need to, I think, no, this is wrong. I definitely need to take into account time. So the start time here needs to push forward the current time. Yeah, the current time needs to be changing stuff. So I think while there's stuff that's active and the earliest active meeting has an end time that is less than or equal to the start time, then I want to remove it from the heap. So active to close end or finished fin end and fin room is equal to the active room, the heap pop from the active heap, and now whatever that room number is, I'm going to say that that's now open. So open room, heap push, open room. I think that's it. And that keeps on doing it while there is something on the heap. And whatever is on the heap is ending before or equal to the start time because it's inclusive of the ending but not exclusive. So if something ends at 5, like this is a kind of important part to get right, whether or not this is less than or equal to. But for instance, right, if the start time was, let's say 2, the start time of this thing is 2. Actually, I don't think of this. Ooh. Yeah, that is right. So if, let's say there was a start time that's exactly 5 and this thing ended at 5, then I want to remove this thing from the heap, where the heap would have, like, this thing would say that the end time of this thing would be 5, and then whatever the room number is. So that thing would get removed, and then, yeah, and then that would be available for, that would be room available for this. And then secondarily, it's possible that the start time here, so if this is 5 and this is, let's say, 12, then anything that is before 12 should get off the heap. So while active, and yeah, the ending time of it is before this current time. So this is remove all meetings, remove all active meetings whose end time is before the start. And then secondarily is, it's possible that there's no meeting that is finished before the start. And in the case where that occurs, and also there's no open meetings at that time, then I need to just remove the earliest at that point. So if no open rooms, move time, yeah, move time to earliest ending meeting. I think this is right. Okay, so if not open room, so there's nothing on the open room heap, then I need to take the earliest meeting. So it would be fin n fin room heap pop active, and then whatever that end time is, that's going to be the current time. So it's going to be heap push onto my active heap, whatever the end time is, fin n plus however long it takes to do this meeting. So this meeting is going to be, start n minus start, comma this room number, and the count of this room number is going to increase by 1. Here I'm not worried about pushing the open room, just to the open room, because it's going to be immediately used for this next thing. Otherwise, I'm going to say that I'm going to say that I assign this room to the open room currently available at this time. So fin room heap pop. No, what am I doing here? I'm going to take off the earliest open room. So room is equal to open room. This should be plural. It's going to be heap of available rooms. Open rooms. There's nothing in the open rooms. Don't do that. Heap pop from the open rooms. And then meet count of this room is going to be incremented. And then heap push onto the active heap the end of this and the room number. And then I do that. And then I do that max count deal. I think this is correct. Let me think. So I start with nothing active. I have my meetings sorted. I look at the start and end, the current index, and then I try to clear off meetings that have finished by this start time, make them available in my open rooms heap, make those room numbers available, and then if there is a room available, like initially, you'll get like room 0 from the heap, increment room 0, add the end time 10 room 0 onto the active heap. Next iteration 1 5 active, there is an active one. The active one's end is 10, which is not before 1, so it's not going to do this. And then there is still open rooms. We'll pull off 1, increment count for 1 to become 1, push onto the heap 5 1. Yeah, I didn't actually incorporate and, did I? No, I did. It's actually the count of open rooms here. And the next one, my index and range n, that's wrong. N should be the number of rooms. I think this should just be the length of meetings. So the next one here, it's going to be 2 7 is the start and end. Well, active, so nothing ends before 2, so nothing gets popped there. There shouldn't be any open rooms at this point, so it's going to take off the earliest ending, which will be the 5 5 1. Push onto it 5 plus 5, so it's 5 10. Room 1, increase room 1, and that's that. And then the next time it goes through 3 4, while active, this is not true. And then here here would take off 10 0 in the heap, push on 10 plus 1, so push on 11, 0. Okay, I think this is good. Keep push. Yeah, that's onto open rooms, the actual room. Probably should have caught that. Alright, cool beans. Okay, so could I improve this? Is there... I think keeping a track of the heap of the open rooms is probably... I think that's pretty necessary. And also keeping track of... I think maybe I can do one small change, and that would be having a dummy active. So let's say I have a dummy active that is infinite as its end time, infinite as its meeting, as its room number. I would get rid of this thing, so I know that it's always possible to have something on the active stack. So I should always be able to compare that dummy. At the very least, there will be a dummy thing that will make this false. So I don't have to check if there's actually anything on the active stack. If not open rooms. I guess I could maybe factor out the meet count of the fin room to become could factor this out a little bit. Do I want to do that? I would have to call this fin room rather than room. It's very similar code here. One is getting the room from this thing. Is pushing the end time. I'm kind of fine with doing this. I wonder how I could improve this. There's the frequency amounts. Guess I never use the actual time variable. I have to sort it. This is pretty necessary. Otherwise, take lowest number open room. Fine as well. I have to know what the maximum amount of count would be, and then find the earliest index where that occurred. Excellent. Random variation. Remove some code. Get a higher result. I mean, I guess having a dummy one does make this thing slightly longer at all times. So maybe that's worse. Yeah, it's all random. Okay, so I'll say for this one, summary would be make sure to, this is really a strong exercise in the use of heaps, which is a data structure that allows for retrieval of smallest element from group. It's pretty much you can initially make it from an array and heapify the array, which is equivalent to where the heapifier of the array is actually going to be equivalent to just these sorting of it. In case, once you have the heap, you just need to know how to take things off the heap, which is using heap pop. Heap pop passing the heap name, and heap push passing the heap name and the tuple that is, or the element that you want to add onto the heap. In this case, the tuple that is the end time and the room number, or maybe just the room number. So basically, go through. Actually, I didn't actually use the index of the meeting, did I? Yeah, maybe I can change that to be a start end in the meetings. I think that still works. Wow, this makes everything slower, whatever. So the summary would be strong exercise in the use of heaps. So you want to keep a heap for the room numbers that are available. Basically are not currently assigned. Which is popped when wanting an open room, and pushed when meetings are finished, and then also keep a heap for the active meetings, tuples, where info for them is stored as end time and room number. So that when an active meeting, so that when the earliest active meeting needs to be found, as in as in example 1 for meeting 2427. It can be quickly determined. So for instance, if you have meetings 0, the first meeting here would be assigned 10, 0. And the second meeting here would be assigned 5, 1. 5 being the start time, 1 being the room number. And then when you need to take something off the heap of active meetings, you take off the 5, 1 before the 10, 0. So that becomes kind of unactive, or that becomes open. And then that open room becomes assigned to this meeting because there's only 2 rooms, right? And then, so in general, create your heaps. Have all rooms in the open room heap. And the active should be like empty or having a dummy event. And then iterate over every meeting, whereby first if start remove all meetings whose start is before the current meetings start, whose end. And then secondarily, try to assign meeting to earliest room, or to smallest room number in open rooms. So, check or basically remove from open room earliest, update count for room, push meeting info onto active room heaps. If no room is available, need to take earliest ending room from available heap and assign meet to that, modifying end time appropriately. So yeah, there's 2 big kind of branches. If there's no room available after you kind of remove all things that end before the start, then you just kind of mimic what would happen if you need to wait for the earliest ending room. Otherwise, just take the openly available room at this time. And then lastly, after loop, determine highest count of meetings in rooms, and return earliest index or earliest room number with that count. So that was this part. Time complexity, it's going to be O of n, or it's actually a O of log n log n, to sort the meetings. Was that necessary? Yeah, I think that was necessary. That was definitely assume that the starting times were processed in order. and O of n to iterate over the meetings. Note here n is equal to is number of events, not number of rooms. Number of rooms generally, actually that's incorrect. Well, O of n to iterate over number, okay, yeah, this is, let's say over, this should be O of k log k to sort the meetings, where k equals number of meetings, and then it's actually O of k log n. Yeah, to iterate over all the meetings, and which would be the n part, well actually which would be the k part, while processing heaps, while working with the heaps in each pass, in each iteration. So this would be the log n part. When we're working with heaps, it's going to have a constant time, like O1 to take the minimum off the heap, but it'll be log of the size of the heap to push stuff onto the heap. Log of the size of the heap. Yeah. Heaps have O1 lookup / removal of smallest element, and O of log h for insertion or adding elements to heap, where h equals size of heap. Yeah. Actually, is that right? How many meetings could there be on the heap at any time? There could be at most the number of rooms. Yeah. Okay. Space complexity, this is going to be O of the heap size. Heap size is k. No. The number of active heaps should be at most k. Most number of rooms, n. Of n to have heaps that track at most n meetings that are occurring, or n rooms that are open. Yeah. Yeah, so very, very straightforward kind of need for heaps here. Want the lowest room number to choose from your active rooms. From your open rooms, and you want the lowest n time to determine what kind of room to assign it to if there's no open rooms. Yeah. And really there's no way around it. Alright, cool beans.